Okay, I've got the top of the hour, so we will get started. Welcome everyone. I hope you're all having a good day so far. The focus of this presentation is on improving energy sector resilience with geocells and ground protection mats. I'm your host, Corey Schneider. I'm a business development manager with Presto Geosystems, and we are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the US and the world. I have everyone muted now, so if you have questions during the presentation, please type them into the question window and I will answer them at the end. Today's presentation will cover geocell development and how geocells are used, specifically in the energy sector, and how they help with touch and step hazards. We'll also discuss our GEOTERRA Construction Mats for both permanent and temporary applications, and highlight some successful GEOWEB and GEOTERRA projects in the energy industry. As mentioned, if you have questions, please type them into the question window and we'll take care of them after the presentation. First, a little background on Presto. We worked with the US Army Corps of Engineers to develop geocell technology in the late 70s and have been innovating ever since. Our products have been used in over 200 countries and in every state in the US. We go beyond simply providing a product. We have a lot of design and construction resources located on our website, which is prestogeo.com. We do also have experienced engineers on staff and do offer free project evaluations. And then we also sell through a distribution network, and they can provide local support as well as contractor support to make sure that the products are not only installed correctly, but also as efficiently as possible. And we do all of this with an eye toward providing a complete solution for your project. We operate in 3 product areas: our GEOWEB geocells for soil stabilization, and these can be used for load support, slope and channel protection, as well as building green retaining walls. We also have a line of porous pavements, both vegetated and aggregate solutions, and lightweight reusable construction mats. We're going to cover a few areas today, focusing on the GEOWEB system in different applications, and then talking about our reusable construction mats. As I mentioned, we worked with the Army Corps of Engineers to develop the geocell system. The initial iteration actually used wax paper so that it would be water resistant, but that wasn't strong enough. Then they tried to make it out of aluminum, which had the strength, but was difficult to ship and install. Finally, high density polyethylene, or HDPE, was the chosen material due to its lightweight, flexible nature and the fact that it is inert to nearly all chemicals and climate conditions. We'll now get into a little general information about our GEOWEB geocells. The GEOWEB system is our version of geocell technology and consists of two main attributes. The first is the cell or container size. The cells come in 3 diameters, small, medium, and large openings, with cell heights of 3, 4, 6, 8, and 12 inches available for each diameter. The proper combination of cell size and cell depth depends on the project details, and we can help you determine which one is the most appropriate for your specific project. There are also 5 section lengths to best fit your project needs and minimize the amount of field cutting that might need to be done. The ultrasonically welded seam, where all of the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell will be. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. GEOWEB is produced using high-quality virgin, high-density polyethylene resin for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our Geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of a geocell system is much more important than stiffness alone. Here you can see a typical GEOWEB panel. It comes tri-folded, banded, and palletized, with each section having a nominal width of 8.5 feet and lengths up to 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. The sections can also easily be cut in the field to fit project dimensions and or go around any obstructions such as trees, manholes, guardrails, etc. The second main attribute of the GEOWEB system is the infill, or what you put in the container. An important benefit of the GEOWEB system is that even a low quality aggregate, sand, or certain salvage materials can be used to infill the cells. Using salvaged aggregate or sand can save significant amount of money on material and hauling costs. We can also eliminate fines when desired, since the cells provide the confinement and aid in the compaction of cohesionless soils. Without fines, you can significantly improve drainage and let the water flow freely through the system, preventing poor pressure buildup and global failure of the cross section. The ability to use sands and low-quality aggregates really sets the GEOWEB system apart from planar geogrids and geotextiles. Those products require high-quality materials with very high friction angles to achieve optimal performance. With the GEOWEB system, low friction angle materials are just fine. The GEOWEB panels achieve their full potential even with these poor materials, which can be a huge cost savings. In order for a geocell system to perform uniformly, it is critical that both the factory welded junctions, which are known as the internal junctions, and the field joined junctions that connect individual panels, or the mechanical junctions, perform at a level that is commensurate with that of the cell walls. Therefore, an incremental improvement in one characteristic, be it cell wall stiffness, environmental stress crack resistance, or any other value, is only valuable if a complementary improvement has been made in the other components of the system. GEOWEB is manufacturing using a proprietary blend of high-quality virgin HDPE, and our proprietary formulation has stood the test of time for more than 40 years, and again, contains no fillers, unstable polymer combinations, or exotic polymer alloys. For most typical sites, GEOWEB will retain its durability for greater than 50 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution as you build with materials you can trust. Our GEOWEB system is also equipped with numerous design and construction components that increase strength and speed of installation. When using stake anchorage, we can provide a simple cap for a standard number 4 or 1/2 inch diameter rebar, or fiberglass or plastic anchors when necessary. The Attra key is used to connect sections together, both side to side and end to end, creating one fully integrated uniform system, no matter how many sections are connected together. It allows for faster installation of the GEOWEB and will last the lifetime of the project, ensuring that the covered area is protected and that the GEOWEB system will not fail under anticipated stresses. The specific engineering values of the ATRA key will ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable ties, connection methods recommended by our competitors. Our spec sheet calls out the specific engineering values for this patented connector. For steep slopes where the native soil is highly erodible or over a surface that cannot be punctured, such as a liner, tendons can be used. The ATRA tendon clip transfers the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real world forces. Now that we've got some background on geocells in general, we'll turn toward the energy sector specifically. The first thing we'll cover is how the GEOWEB system works at the surface to create a stabilized, unpaved road. An aggregate surface has advantages in saving pavement costs, and with the GEOWEB system filled with open graded base course, you can design a system that allows stormwater infiltration and provides stormwater storage. The purpose of cellular confinement is very simple: to stabilize the movement of unstable soils, both horizontally and vertically. The weaker the subgrade conditions, the more practical the insertion of the GEOWEB system is into the design. There are many great benefits to using the GEOWEB system, but the one I really want to highlight again is that we do allow for the use of sand, low quality aggregate, or on-site or salvage materials so that you don't have to truck in expensive engineered stone. This is a big benefit over other geosynthetics, as I mentioned previously, that would require specific gradations of high quality stone. Additionally, by controlling differential settlement, GEOWEB can greatly reduce or even eliminate rutting, helping to control maintenance costs. On the construction end, the panels can be installed in any weather conditions and allow for immediate access, unlike when chemical stabilization is used. And it can also reduce your overall cross section by 70% compared to non-reinforced sections. The GEOWEB system is suitable for use in extremely soft subgrade conditions, and in fact, the worse the subgrade is, the more sense the GEOWEB makes. Here you can see the impressive load support benefits of a 80,000-pound loaded dump truck with 100 PSI tire pressure on a partially filled GEOWEB panel over soft subgrade. You can see how the cells push back against each other to support the load, and that only the adjacent cell needs to be filled for support. A great benefit to using the system is that you don't need to have every cell completely filled before the road is usable. You can reduce construction time and materials with this approach, which is a significant benefit of using the GEOWEB system. The system works this way. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell to form a stable system. Each cell helps support the ones around it. The GEOWEB cell walls also transfer hoop stress, which is important in keeping the system intact and creates a mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the geocell system can improve load-bearing capacity. Strong seams, semi-ductile resin properties, and integrated connections are critical to a well-performing system. Here you can see the stresses on the subgrade with the unsupported subgrade on the left and the GEOWEB reinforced section on the right. Notice how there's a complete elimination of the highest stresses at the surface with GEOWEB reinforcement. The stresses are reduced and distributed over a wider area, which again is known as the mattress effect. This reduces stress reaching the subgrade and leads to a significant decrease in deflection and rutting. By eliminating lateral particle movement, the GEOWEB system can stabilize the surface, eliminating the need for constant maintenance. Now we'll look at a few project profiles. This first one was for the Wheatstone liquid natural gas facility in Australia. The equipment was brought in by ship, assembled at the port, and then moved 10 miles inland to the facility. The vehicle used to move the equipment was quite large, as you can see here, so the roadway had to be built strong enough to handle the load without rutting or settling. The high number of passes was also a concern, as the heavy loads would cause some serious damage to pavement over time. We worked with the project engineer to design an aggregate surface roadway that would withstand the vehicle's stresses and that could be built quickly in a remote environment. This solution used 2 layers of GEOWEB, which is quite rare, with the top layer intended to absorb stress and help evenly distribute the loads, and the bottom layer in place to aid in compaction and reduce settlement. Here's a good photo of the construction sequence for this road. So you've got the port in the upper right-hand corner here, heading to the liquid natural gas facility in the lower left. The geotextile, which is the white area here, goes down first on the native subgrade. Then the GEOWEB panels are installed. So you can see some partially filled GEOWEB panels here as we work back towards the port. And then you can see the native on-site material being used for the infill material as you travel back. Being able to use the excavated material was a huge bonus to the GEOWEB system here, since it would have been very difficult to get the required amount of engineered stone out to this remote site. Here's a project that was creating an access road to oil resources in Western Canada over undeveloped, soft, spongy subgrades. You can see again that readily available sand infill was used, so expensive aggregate wasn't necessary to transport in. In most cases, the system can also reduce the depth of the cross-section by 70% or more. And on this particular project, we reduced the original section of 40 inches of imported aggregate to a total depth of 8 inches using an enhanced woven geotextile, 6-inch GEOWEB filled with the on-site sand, and then 2 inches of imported aggregate for the wearing surface. Now we'll take a look at a Duke Energy project in Florida where they had to install new transmission towers through a wetland area. This was back shortly after the high winds of Hurricane Michael demolished over 100 towers, all of which had to be restored over this extremely wet subgrade. In this case, again, we used an enhanced woven geotextile over the subgrade. Then the GEOWEB material and sand infill were placed, creating access and maintenance roads, as well as pads around the towers. And all told, about 2 million square feet of GEOWEB panels were used, with the system acting as both the construction access and long-term maintenance road. You can see here the natural subgrade through this location. The water table is basically at the surface, and boot prints are more than 1 inch deep, which means the sand here is extremely soft and definitely can't support trucks or construction equipment without additional support. On this project, we used Mirify's RS580i as the geotextile, which has a tensile strength of over 5,000 pounds per foot and additionally has wicking capabilities, quickly moving water out of the pavement section. The GEOWEB system works well with pretty much all other geosynthetics to create the best solution for a given project site, depending on loading requirements, drainage issues, or any other concerns you may have. Here we are mid-installation. You can see the empty GEOWEB panels in the background of the photo. And again, during construction, the contractor can use the GEOWEB road as soon as it is filled in, which is quite useful when you're trying to minimize the impact of construction on the surrounding environment. Now we're over to a different Duke Energy project in Florida, again through very wet, soft soils. In some locations, there are actual low water crossings where water would be slowly flowing over the top of the road, which is not a problem when using the GEOWEB system. Given site hydraulic conditions, we can even recommend the required stone size to prevent long-term washout, which we'll discuss more a little bit later. Because it was important to not interrupt the potential water flow through this wetland area, a high-quality open-graded aggregate was used as the infill. The GEOWEB panels themselves don't impede water flow since they are approximately 20% open on the sides, so there is minimal disturbance to the environment, which is sometimes required by local regulations. Here's the completed access road. It's perfectly fine to see the top of the GEOWEB panels in roads like we see here. The system is fully functioning and you aren't going to damage the panels as long as they remain full. Now we move on to a substation access road in Louisiana, which was originally designed with geogrid reinforcement, but they came across some subgrade California bearing ratio values that were lower than anticipated. So they switched over to a GEOWEB solution with sand infill. Notice how easily curves are created. The orientation of the GEOWEB, whether it's expanded across the width or down the length of the roadway, has no bearing on the effectiveness of the system. Whichever direction makes sense based on the roadway dimensions is acceptable. Again, we get an idea of the construction process. You can dump the infill material in piles directly on the GEOWEB panels, then rake or use a dozer to push the material into the open cells to infill them. And again, we've got the partially completed access road on the left and fully completed on the right. GEOWEB access roads can also be built on quite steep slopes. Anchorage will be required to hold everything in place, and we can help determine what is needed based on the expected vehicle loads and slope angles. Here we have the beginning of the infill process, which is always recommended to take place from the top of the slope down. Not only is it recommended, but it's also easier as you can allow gravity to assist with the infilling process. And you've got your completed access road with aggregate fill. Next, we'll move on to a wind farm project in Germany using a combination of sand and aggregate infill from on-site sources. Large equipment was used to move the wind turbines, so this road had to be very durable. A typical wind turbine will require 50 concrete trucks, steel reinforcement, the tower, the blades, and the turbine accessing the site over the course of a few months to build the turbines. Axle loads are usually around 20,000 pounds. In order to handle these loads, 12 inches of sand was confined within the GEOWEB panels, which helped distribute the load and significantly reduce the vehicle stress seen by the native subgrade. Again, note the geotextile that was placed below the GEOWEB panels for separation. Notice the ruts that are occurring where the cells are overfilled, but the rutting does stop right at the top of the cell walls. This is exactly how the geocells are supposed to function. The overfill material is called a wearing surface and helps compact the material into the GEOWEB cells as it is driven over. And again, we've got the completed project with the wind turbines going up. You can see the large crane in the background for an idea of the types of vehicles this GEOWEB system can support. So one of the biggest questions we get is always about cost, which is not surprising, especially if this is a new technology for you or for your area. Having an idea of how much the GEOWEB system costs compared with other stabilization techniques is very important. So here we have a basic comparison for the GEOWEB system in a load support application, in this case, a gravel surfaced road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GEOWEB system, one with aggregate and one with salvaged on-site materials as the infill. You can see that the GEOWEB system is both thinner and less expensive than the other methods, significantly so when on-site material is used. In fact, you have about a 40% cost savings compared to the geogrid geotextile section, which again will not allow for the use of most salvaged or on-site material, as they generally require a high friction angle, well-graded material be used. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that can be achieved. Just to point out here specifically, GEOWEB with on-site materials, you're at about $18.50 a square yard. That geogrid geotextile section is all the way up in the $31 a square yard area. Next, we'll briefly discuss the benefits of using GEOWEB at electrical substations. GEOWEB works quite well in these locations which have some pretty specific requirements and needs to help protect workers. Using an open graded base course is essential and easy to do with the GEOWEB system, and compared with an unreinforced system, there is very little maintenance required over time. The GEOWEB system will allow for water drainage and doesn't need to be heavily compacted, so it is quite quick to install. For this project in Tampa, Florida, the system was used both as the access road to the site and the working platform around the transformers. Again, it will allow for good water infiltration, so you won't have any ponding at the surface, which can be a big safety hazard on electrical sites. As many energy projects need to deal with stormwater and potentially steep slopes, we'll now go over to both channel and slope protection, starting with channels. A typical section might have concrete or aggregate below normal water level, depending on the flow characteristics. And many times we can allow for transitioning to topsoil and vegetation in the flood zone in order to provide as natural looking of a section as possible. Can be placed along the embankments of stormwater channels and ponds to help prevent erosion due to fluctuating water levels. Low flow situations are easily handled by vegetated GEOWEB systems, creating natural looking embankments without intensive maintenance requirements. The GEOWEB system does not need to cover the bottom of the channel if continuous low flow water is present, and the type of vegetation selected within the panels is not really important to the function of the system. So choosing plants that are native to the area and can handle an occasional soaking will be a big help in reducing potential maintenance. The vegetated system will be lower cost than a riprap lined channel, since you can use local topsoil and you don't need to import large riprap stones. There's less maintenance as well, since riprap channels need constant inspection to replace lost stone and remove weeds. With a vegetated channel, the only maintenance is the occasional mowing, which can be done with a standard mower, so you don't need any special equipment. And finally, vegetated channels have better aesthetics than riprap channels. It may not seem that way, but vegetated channels are actually a good solution for higher flows when stabilized with the Geocell technology and a turf reinforcement mat overlay. The improvement is incredibly high, up to about 29 feet per second and 16 pounds of shear, compared to just 5 to 6 feet per second when erosion blankets are used. This allows for lower impact vegetated channels to be used instead of that expensive high maintenance riprap, concrete, or articulated concrete blocks. One of the best things about our system is how much we trust that the system will work, and that is because we have the experience and research to back up our claims. Significant testing has been done at Colorado State University in Fort Collins, which is considered one of the top hydraulic research facilities in the world. The facility is unique in that it is located under the Horseshoe Reservoir and has a couple hundred feet of static head, allowing it to achieve extremely high velocities and shear stresses in both their indoor and outdoor flumes. Vegetated infill testing was performed with two objectives in mind. The first was the ability to withstand high velocities and shear stress. And the second was that we wanted to compare the performance of our topsoil filled system versus riprap and other conventional solutions, such as erosion blankets and turf reinforcement mats. The testing consisted of 6-inch deep GEOWEB panels filled with topsoil and a mid-grade TRM surface protection. Vegetation was established and grown to 6 inches to replicate typical field conditions. A total of 10 one-hour tests were performed in the outside flume with varying conditions, including flow rate and bed slope. The testing was done in accordance with ASTM D6460 standards, which covers both soil loss through scour and blade density. The ASTM standard considers a successful test where you have less than 1/2 inch of topsoil loss and at least 300 blades of grass per square foot. The blade density is important as vegetation growth is a key factor in overall long-term stability. Our vegetated channels hold up really well against even turbulent flows, such as around corners or near rough terrain. Again, most people wouldn't think that a vegetated channel can withstand much water, but when properly confined in the GEOWEB system and using surface protection, velocities of almost 30 feet per second and shear stresses of 16 pounds per square foot can be achieved. Here you can see one of the tests where the vegetated GEOWEB is actually under about 6 inches of water in the flume. Of course, there are a lot of different types of grasses, and choosing hardier varieties will improve these results while still blending in with the surrounding areas. And here we have a quick comparison to show the impressive results. You can see that the GEOWEB filled with topsoil, again, can handle 29 feet per second. And when we compare that to 12-inch riprap, you're down to about 14 feet per second. And it also far outperforms high-performance turf reinforcement mats alone, doubling the acceptable velocity and shear stresses. The key takeaway is that topsoil-filled GEOWEB provides twice the protection of 12-inch riprap as well as high-performance TRMs. And as an aside, we also tested the unvegetated condition and learned that the GEOWEB improves the unvegetated performance of a turf reinforcement mat by 30%. So you do get day one advantages in addition to the long-term benefits. This solution is suitable for any situation where you have very high velocities but short duration flows. It allows you to maintain vegetation in areas that would previously have been concrete or very large riprap. So we also tested our aggregate channels, and for these tests we did 3 different cell sizes and 2 different rock sizes and ran a total of 90 different tests. With all of these data points, regression analysis was able to be undertaken. So we do have a regression equation which allows us to perform analysis. And now, given the bed slope and unit discharge of a particular channel, we can manipulate the rock size and the cell size until we get to a point where your rock loss L is 0. When compared to traditional riprap sizing tools by Abson Johnson and the Corps of Engineers, GeoWeb channels can reduce your rock size from 2 to 10 times, offering significant cost savings. The large variance is due to bed slope. The flatter the bed slope, the greater we're going to be able to reduce your rock size. And finally, concrete-filled channels. This particular project is a water conveyance channel in Colorado. The section consisted of a geomembrane, then a geotextile, followed by our mid-size cell 3-inch depth GeoWeb filled with 3,000 PSI concrete. Tendons were used for anchorage as we couldn't puncture the geomembrane. And studies by the US Bureau of Reclamation show that concrete-filled GeoWeb is the most cost-effective, lowest maintenance solution for water conveyance channels. The installation is really quite simple with concrete. Once you've got the GeoWeb anchored onto the slopes, it will act as a concrete form. So you can just pump the concrete directly into the cells or pour it into the cells if you have access for that. Then you simply screed and finish to the top of the cells. Notice in the picture on the right the flexibility of the system. Because each cell wall basically acts as a joint, it won't crack like poured in place concrete will. And again, we had very impressive results for the concrete filled version of the system at Colorado State. Also, being able to withstand 36 feet per second and 21 pounds of shear without failing the system, but rather we maxed out the flume. So a quick summary of the GeoWeb channel protection benefits. We will improve the hydraulic performance of whatever infill material you use. With vegetation, we'll promote infiltration and reduce runoff. With an aggregate infill, you can use smaller, less expensive rock. And then with concrete infill, no other forms are required, and it will flex with subgrade deformation, minimizing cracking. And next we'll go on to slope protection briefly. So the benefit of using GeoWeb on slopes is that it will allow for steeper stabilized slopes that are resistant to erosion when compared to other methods. We list 1 to 1 or greater on here. We can really do this slope protection system on any globally stable slope. If it's globally stable, we can design an anchorage method to hold the material on the slope and allow you to infill with a variety of different materials. So it works in multiple ways to protect the slope surfaces. It prevents significant movement of the soil by confining it to individual cells. By separating the soil into smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads and prevents soil erosion. It's important to emphasize that proper installation of the GeoWeb includes embedding the sections into the crest of the slope. This will prevent water from flowing beneath the GeoWeb and undermining the system. The system provides a way to fully vegetate slope surfaces that otherwise could not support sustainable plant life, and increases the overall slope stability by interlocking with the vegetated root zone. Stone and concrete materials can also be confined within the GEOWEB panels, again on slopes that would normally be too steep to allow for natural stone slopes. Vegetated slopes are the most popular option for slope protection because they can result in the most attractive slopes with little to no maintenance. So again, we can use a variety of different infill materials. Vegetation is usually the one selected, but a lot of times that isn't an option or is not appropriate depending on the environment. So we can also do stone and concrete. There are a lot of different options for the cross sections on a slope depending on the project details and needs. As mentioned previously, different types of anchoring are available, and our engineering evaluations can help determine the best system for your project needs so that you know that you're getting something that works and not a one-size-fits-all solution. Now we'll look at a couple of slope and channel project profiles in the energy sector. Here we have sandy soils around the support structures for this pipeline in California, and they were experiencing some significant erosion due to wind and water flow. There was no vehicle access to many parts of the pipeline because the sandy soil just couldn't handle the loads. And as you can see, we had grades of up to 45%. To both protect the support and allow pipeline maintenance access, the GEOWEB system filled with concrete was used. The system was fast and easy to install, even in this remote location. Here's a different project with the idea being to fix a deteriorating liquid natural gas facility. They needed to reface the primary and secondary dikes without disturbing them so that the facility did not have to shut down during construction. And the original asphalt cover along the face of the containment dikes had deteriorated. And we had slopes of 1.2 to 1 on the primary dikes and 2 to 1 on the secondary. So due to the different slope angles and slope heights, we use different anchorage methods. The GEOWEB system was a great solution because it was able to be integrated into all necessary locations with minimal changes required. Here we have some photos of the installation of the primary dike slope, and then the completed system with the secondary dike in the foreground and the primary dike in the background. The largest solar farm east of the Rockies at 3,500 acres, the Spotsylvania Solar Farm has hundreds of detention ponds to handle stormwater runoff. A 2 to 1 slope into one of the ponds at the back of the site was causing the owner particular problems as it had to be repaired several times using stone check dams, erosion control blankets, and turf reinforcement mats, with nothing working due to the large volume of water, the slope of the drainage area, and the fact that there is a road right at the top of the damaged slope, leading to high volumes and velocities. Eventually, the GEOWEB slope protection system was chosen as a solution. The slope was smoothed out and the GEOWEB panels placed over the prepared slope using the tendon system for anchorage. The tendons were tied to a deadman pipe buried in a trench at the crest of the slope. Then the trench and GEOWEB panels were filled with locally available topsoil. The slope was then hydroseeded and covered with a straw coconut blanket. Just 2 weeks after the install, after several high-intensity storm events, there is significant vegetation established with no gullies or rills forming. While the GEOWEB system may not be the cheapest material available, it can solve the most challenging erosion protection issues. And think of the cost savings if this solution was selected in the first place and the slope didn't have to be redone 4 times. And now we'll finish with a brief discussion of our reusable, lightweight GEOTERRA construction mats. When you need access quickly for a temporary solution, our construction mats are the way to go. They are intended to be placed directly on top of the existing grade, generally with a geotextile separation layer placed first, and don't need any infill material. The mats can support both tracked and wheeled equipment and vehicles. Testing from the University of Kansas show that they are structurally equivalent to 12 inches of aggregate, offering significant savings in both placement and removal, as well as reducing the overall carbon footprint of the project. So we have two versions, the GEOTERRA and the GEOTERRA GTO. And with each of these, we recommend different laying patterns based on direction of traffic. Generally speaking, we want to create a layout that avoids long continuous seams. This is true of both the bricklayer and herringbone patterns, with the bricklayer suitable for unidirectional traffic and the herringbone for multi-directional. The side-by-side pattern that you see in the lower right-hand corner can be considered for relatively lightweight and or very short-term installations. Depending what we're trying to accomplish, several different geosynthetics can be incorporated into the cross sections as well. So design 1 and 2 that we see here are used to prevent rutting, protect turf over sand, and or to create a uniform stable surface. With this section, we add the geotextile separation if we're worried about subgrade pumping. Design 3 is used for the same purposes, as well as to prevent subgrade degradation and contamination. So in this case, a geomembrane is added to prevent infiltration of surface water. Design 4 is suitable for over poor wet soils to prevent rutting and to create a uniform stable surface. And with design 4, we incorporate a geonet to create an integrated drainable surface. And then finally, design 5 pretty much does it all, as we add the geomembrane as well as the geonet. Regardless of what you are trying to accomplish, we should be able to provide you a solution. So I mentioned we have two different types of mats. Here you see the GEOTERRA GTO, which uses a plastic bolt connection method, making installation relatively fast. Here we see some of the specs of this product. Bottom open area of about 20%, about 4.3 square foot per unit. And this one is made out of a virgin polyethylene blend and has a 550 PSI crush strength. And again, the units are locked together with bolts to form a network of interconnected structural mats. And we can install about 150 square feet per man hour when we use a cordless drill for the installation. And here we see version number 2, the GEOTERRA, one of the lowest cost, if not the lowest cost, structural mats on the market today. The units are slightly larger than the GTO units at nearly 5 square feet each and weigh just 9 pounds. So while the crush strength is less than the 550 PSI of the GTO mats, at 420, it is still nearly 4 times the loads applied in HS25 loading. And again, our research from the University of Kansas showed that both of these are structurally equivalent to 12 inches of aggregate. The GEOTERRA is connected together using the 2-piece padlock connection device. And the padlock allows for pre-assembling larger mats either on or off site to provide efficient transportation and installation. With the GEOTERRA mats, connections are a little slower, so we get about 100 square feet per man hour when assembled on a hard surface. And again, these mats are easily transported as large mats on trucks or even by helicopter. And the units only weigh 2 pounds per square foot, so you really don't need any construction equipment to drag them out onto site. And now we'll go through a couple of quick project profiles on the construction mats. The GEOTERRA construction mats were used to access many of the non-paved areas of this natural gas refinery down in South America. Equipment storage was moved around as needed, so the temporary and reusable nature of the GEOTERRA mats was key. They also provided a place to keep equipment high and dry out of the wet clay subgrade, and it made it much easier for the workers to move around as well. And this project was located in the Amazon jungle, so they did not have a local aggregate source, making traditional construction methods impossible. They also use the GEOTERRA to construct helipads in order to fly material and personnel in and out of the project sites. The mats can be painted with signage as needed and then cleaned if reused at another location. They can be used in very wet environments as well. This project needed a solution for quick access over soft ground. The water moved through the mats as needed without compromising the integrity of the system for the vehicles. Again, they're typically going to be placed over an enhanced geotextile, especially over soft ground like we see here. And the geotextile will help provide a little bit of extra strength to the system and prevent the mats from sinking into the subgrade. And again, they are lightweight and easy to move. One trick to help keep things moving is to pre-assemble the mats into sections that can fit on a truck for quick and easy deployment. So a few slides in closing. As mentioned a few times, we provide a complete solution, and part of that is our technical assistance. The engineering team here at Presto works closely with landscape designers and engineers, offering a free project evaluation service for any roads, embankments, or erosion control projects. The form is on our website, which again is prestogeo.com. You can fill it out with as much information as you have, including attaching documents such as geotechnical reports. Once submitted, within 3 business days, but usually faster, we can provide a complete design evaluation, including infill recommendations, anchorage requirements, and design calculations. We will work with you to get you the best solution for your project. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. We are now making it faster and easier for you to obtain your PDH certificates. With our new webinar dashboard, you can easily view our webinars and download PDH certificates for on-demand and live webinars. Your webinar dashboard will keep a record of all on-demand webinars completed, along with PDH credits earned. A link with more information and instructional videos will be emailed to you within the next couple of days. Those of you who are in attendance today will automatically receive a PDH certificate within the next 24 hours. Note, these emails will come from GoToWebinar and not from Presto, so be on the lookout for it. Depending on your company's cybersecurity setup, you may want to check your spam folder at the end of the week if you haven't received your certificate. So again, here's my contact information if any questions come up in your mind later. But right now I will take a look at the questions that have been submitted during the webinar. We'll go to the top here. Does GEOWEB system eliminate erosion blow? If you use an aggregate infill or at least an aggregate surface course, it will eliminate that wind erosion. With a sand infill though, you could still be subjected to some wind erosion. So In a sandy, windy environment, I would recommend at least an inch or two of an aggregate wearing course. Next one, where there is a high water table, are the porous walls of the cells not prone to clogging with silt after a period of time, hence causing flooding or floating of the system. We actually have not really seen that happen. The openings in the cell walls are, I believe, 3/8 of an inch, 3/8 inch diameter circles. So they're quite open, and we really haven't had any issues with the cell wall openings clogging over time. How do you make sure that there are no large voids left within the GEOWEB? Such voids may result in localized settlement over time. Well, we do recommend roller compaction after the infill. So as long as you do roller compaction over the whole area, you should not have an issue with any large voids in the cells. When concrete is used, the perforations on the walls of the GEOWEB will not exist. That is incorrect. The perforations will still be there, and this actually helps to lock the concrete up within the individual cells as the concrete can flow in between the cells. Will the slides be made available to attendees? Typically, we do not make them available, but if you do want to send me an email to the address right here on your screen, Corey.Schneider@PrestoGeo, I can create a PDF document and email it to you. Will the PDH certificates be emailed? Yes, they will. Any information on life expectancy? Yeah, as I mentioned early in the presentation, you can certainly be confident that this material will last 50+ years. We have done accelerated lab tests when even completely exposed to sunlight and the environment, they don't begin to break down for over 150 years. And then one final question for slope protection: what type of aggregate infill material is recommended? Generally speaking, we want the maximum particle size of the aggregate to be about 1/3 the cell depth. So if you use a 6-inch cell, you would go with 2-inch minus. A 4-inch cell, you'd be more at 1.25 inch minus. And a lot of that might depend on your slope angles and how much sheet flow you have coming over the system, because the steeper the slope and the more sheet flow, we would want to use a larger rather than a smaller aggregate. So we would possibly increase the cell depth to allow for that. So that looks like it takes care of all of the questions, and at 11:58 puts us just under 1 hour. So I do again want to thank everyone for attending today. If there are any questions that weren't answered, again, you can send me an email or give me a phone call. Hope everyone got something out of this webinar, and I hope you join us on ones in the future. Thank you and have a good day.